Hello my dear student. Today we will be discussing about important concept, that is Morden adsorption theory. So before discuss this concept, first we recall some important concept from yesterday class. So that is catalysis. So tell me, what do you mean by catalysis? So here catalysis means the phenomena of changes the rate or velocity of reaction by adding catalyst. So this is called as catalysis. So here these catalysis are classified into two categories. First one is homogeneous catalysis. Second one, heterogeneous catalysis. So here, tell me, what do you mean by homogeneous catalysis? So here, in catalytical reaction, both reactant and catalyst are in same phase or same state. This is called as homogeneous catalysis. Consider, for example, sulfur dioxide undergo oxidation in presence of nitric oxide. So here formation of sulfur trioxide take place. So in this case, sulfur dioxide also it is in gaseous form, oxygen is also gaseous form, and nitric oxide is also gaseous form. So therefore, this example belongs to homogeneous catalysis. Okay. So next one, heterogeneous catalysis. So heterogeneous catalysis means, so here reactant and catalyst in different phase. In different phase. So this is called as heterogeneous catalysis. For example, vegetable oil here, vegetable oil hydrogenation in presence of finely divided nickel as a catalyst to form vegetable ghee. So here in this case, vegetable oil it is in liquid phase, hydrogen it is in gaseous phase, nickel it is in solid phase. So here in this heterogeneous catalysis, so here both reactant and catalyst are in different phase. So here these are the concept of yesterday classes. So next we move towards the Morden adsorption theory. So here already we know that what do you mean by adsorption. So tell me, what do you mean by adsorption? So here the phenomena in which molecular, atomic or ionic species of one substance accumulated on the surface of another substance. So this is called as adsorption. Okay. So here this Morden adsorption theory, it is a combination of old adsorption theory and formation of intermediate compounds. Heterogeneous catalysis is regarded as surface phenomena in which catalytic activity is located on the surface of catalyst. So here the heterogeneous catalysis involves following steps. So here first one is diffusion of reactants on surface of catalyst. Second one, adsorption of reactants reactants take place on the surface of catalyst. Third one, chemical reaction occurs at the surface of catalyst through intermediate state. Fourth one, desorption of product from the surface of catalyst. Desorption of product from the surface of catalyst to make surface of catalyst free for further reaction. Then fifth one, diffusion of product away from the catalyst. So these are observations of Morden adsorption theory. So here, consider first one, diffusion of reactant on the surface of catalyst. So now consider catalyst. So this is catalyst. So here, diffusion of reactant. So here A and B are reactant. So here diffusion of reactant on the surface of catalyst. So here next one, adsorption take place. Second case, adsorption take place on the surface of catalyst. So here second one, adsorption take place on the surface of catalyst. So here adsorption of reactant on the surface of catalyst. So next, third one, chemical reaction take place. On the surface of catalyst through formation of intermediate. So here chemical reaction take place at the surface of catalyst. The formation of intermediate. So next, fourth one. So here desorption of product. So what do you mean by desorption? So already we learned in previous class, desorption means removal of adsorbate molecules from the adsorbate. So this is called as desorption. So here, desorption of product from the surface of catalyst. We get catalyst or so here we get catalyst surface free for further reaction. So here desorption of product from surface of catalyst. Desorption of product from surface of catalyst to make surface free for further reaction. So here desorption is take place. Fifth one. So here diffusion of product away from the catalyst. Diffusion of product away from the catalyst. So here this is about the Morden adsorption theory. So nodi nage kalakade Morden adsorption theory kalakade. So Morden adsorption theory in formation agati. It is a combination. In combination agati old adsorption theory ಮತ್ತು formation of intermediate compound. Okay. So heterogeneous catalysis ಇದಕ್ಕೆ ಏನು ಕರೀತೀವಿ ನಾವು? ಇಟ್ ಇಸ್ ಅ ಸರ್ಫೇಸ್ ಫಿನಾಮಿನಾ ಅಂತಂದ್ರೆ catalytical activity ಎಲ್ಲಿ ನಡೆಯುತ್ತೆ? ಸರ್ಫೇಸ್ ಆಫ್ catalyst ಒಳಗೆ catalytical activity ನಡೆಯುತ್ತೆ. ಹೌದಾ? ಸೊ ಇಲ್ಲಿ ನಾವು ಏನು ಮಾಡಿವ 5 ಅಬ್ಸರ್ವೇಷನ್ ಐತಿ. ಮೊದಲನೇ ಅಬ್ಸರ್ವೇಷನ್ ಡಿಫ್ಯೂಷನ್ ಆಫ್ ರಿಯಾಕ್ಟೆಂಟ್ ಆನ್ ಸರ್ಫೇಸ್ ಆಫ್ catalyst. ರಿಯಾಕ್ಟೆಂಟ್ ಏನು ಮಾಡ್ತಾರೆ? ಸರ್ಫೇಸ್ ಆಫ್ catalyst ಗೆ ನಿಯರ್ ಬರುತ್ತೆ. ಹೌದಾ? ಸೆಕೆಂಡ್ ಒನ್ adsorption of reactant take place on surface of catalyst. ಈ ರಿಯಾಕ್ಟೆಂಟ್ ಏನು ಮಾಡ್ತಾವೆ? catalyst ಒಳಗೆ ಡಿಫ್ಯೂಷನ್ ಬಂದ್ಬಿಟ್ರೆ adsorption ಆಗುತ್ತೆ. ಅಂದ್ರೆ ಈ ರಿಯಾಕ್ಟೆಂಟ್ catalyst ಒಳಗೆ ಏನು ಮಾಡ್ತಾವೆ? adsorption ಆಗುತ್ತೆ. ಹೌದಾ? adsorption ಆಯ್ತು ಅಂತ ಥರ್ಡ್ ಏನೈತಿ? chemical reaction take place or occurs at the surface of catalyst through intermediate state. So second step adsorption ಆಗೈತಿ. ಸೊ ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್ adsorption ಆಯ್ತಪ್ಪ ಅಂತಂದ್ರೆ ಥರ್ಡ್ ಸ್ಟೆಪ್ ಗೆ ಏನಾಗೈತಿ? chemical reaction ಆಗೈತಿ. chemical reaction ಎಲ್ಲಿ ಆಗೈತಿ? surface of the catalyst ಮೇಲೆ ಆಗೈತಿ. chemical reaction ಆಗೈತಿ. ಸೊ chemical reaction ಹೆಂಗೆ ಆಗೈತಿ ಅಂದ್ರೆ to the formation of intermediate. ಇಲ್ಲಿ ನೋಡಿ ಇಲ್ಲಿ ಬಾಂಡ್ ಇಲ್ಲ, ಜಸ್ಟ್ ಆಗೈತಿ reactant A and B ಅನ್ನು adsorb ಆಗ್ಯಾವ. ಈ ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್ ದಾಗೆ ಥರ್ಡ್ ಸ್ಟೆಪ್ ದಾಗೆ ಏನಾಗೈತಿ? ಇಲ್ಲಿ reactant A and B ಅನ್ನು ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ ಮಾಡ್ಯಾವ. ಅಂತಂದ್ರೆ ಏನಾಯ್ತು? intermediate state formation ಆಗೈತಿ. intermediate state ಅಂದ್ರೆ ಏನು? it is an unstable state. It is unstable state and it readily undergo decomposition. So third step ದಾಗೆ ಫಾರ್ಮೇಷನ್ ಆಯ್ತು, chemical reaction ಆಗಿಬಿಟ್ರೆ intermediate formation ಆಯ್ತು. fourth step ದಾಗೆ ಏನಾಯ್ತು? desorption ಆಯ್ತು. desorption ಅಂದ್ರೆ ಏನು? adsorb ಆಗಿರ್ತಕ್ಕಂಥ molecules adsorbment ಬಿಟ್ಟು ಹೊರಗೆ ಹೋಗ್ಬೇಕು desorption ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಇಲ್ಲಿ fourth step ಒಳಗೆ so desorption of product from the surface of catalyst. ಸೊ ಇಲ್ಲಿ ಏನಾಯ್ತು? reactant molecules product ಹೊರಗೆ ಹೋಗ್ಬೇಕು. ಸೊ ಇಲ್ಲಿ ಏನಾಯ್ತು? surface of catalyst ಆಯ್ತು ಅಂತ ಮತ್ತೆ ಫ್ರೀ ಆಯ್ತು. ಯಾಕೆ ಅಂದ್ರೆ further reaction ಆಗುತ್ತೆ. So fifth one diffusion of the product away from the catalyst. So formation ಆಗಿದ್ದ product ಏನಾಯ್ತು? catalyst ಬಿಟ್ಟು ದೂರ ಹೋಗ್ಬಿಡುತ್ತೆ. So here so this is about the Morden adsorption theory. Next we move towards the important feature of solid catalyst. Important features of solid catalyst. So here the solid catalyst may be metals, alloys, metal oxide or metal sulfides. So here the effectiveness of these catalysts depends on two aspects. First one is activity, second one is selectivity. First one activity, second one selectivity. So solid catalyst ಯಾವ ಇರಬಹುದಪ್ಪ ಅಂತಂದ್ರೆ ಮೆಟಲ್ ಇರಬಹುದು ಅಥವಾ ಅಲಾಯ್ಸ್ ಇರಬಹುದು ಅಥವಾ ಮೆಟಲ್ ಆಕ್ಸೈಡ್ ಇರಬಹುದು ಅಥವಾ ಮೆಟಲ್ ಸಲ್ಫೈಡ್ಸ್ ಇರಬಹುದು. ಓಕೆ, ದ ಇಫೆಕ್ಟಿವ್ನೆಸ್ ಹೆಂಗ್ ಇಫೆಕ್ಟ್ ಆಗ್ತಾವು ಈ ಸಾಲಿಡ್ ಕ್ಯಾಟಲಿಸ್ಟ್ ಇದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರ್ತದೆ ಅಂತಂದ್ರೆ ಮೇಲಿ ಟು ಆಸ್ಪೆಕ್ಟ್ಸ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. ಒಳ್ಳೆ ಆಸ್ಪೆಕ್ಟ್ಸ್ ಯಾವುದು ಅಂತಂದ್ರೆ activity, second one selectivity. So first we discuss activity. So here the ability of catalyst to increase rate of chemical reaction. So this is called as activity. So here the ability of catalyst to increase rate of chemical reaction. So this is called as activity. So activity ಅಂದ್ರೆ ಏನು? The ability of catalyst catalyst the capacity to increase the rate of chemical reaction. So this is called as activity. So here ability of catalyst to increase the rate of chemical reaction. So here the activity of catalyst depends on strength of activity of catalyst depends on strength of chemisorption. So here the activity of catalyst it is based on or it depends on strength of chemisorption or chemiadsorption. So tell me, what do you mean by chemisorption or chemiadsorption? The phenomena where adsorbate is held at the surface of adsorbent by chemical bonds. So this is called as chemisorption. So here what do you mean by chemisorption or chemiadsorption? Phenomena where adsorbate is held to the surface of adsorbent by chemical bonds. So this is called as chemisorption. So here the activity of catalyst is depends on strength of chemisorption. The reactant adsorb strongly. The reactant adsorbs strongly for catalyst to be active. So here the reactants adsorb strongly for the catalyst to be active. So reactants ಹೆಂಗೆ adsorb ಮಾಡಬೇಕು ಅಂದ್ರೆ catalyst active adsorb ಮಾಡ್ಕೋಬೇಕು. So ಹೆಂಗೆ ಸಾಧ್ಯ ಆಕೈತಿ? ಸೊ ನೋಡ್ರಿ reactants ಇದ್ದು catalyst ಮೇಲೆ ಬಂದು ಅಪ್ರೋಚ್ ಆಯಿತು ಅಂತಂದ್ರೆ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಫಾರ್ಮೇಷನ್ ಆಕೈತಿ. ಸೊ ಪ್ರಾಡಕ್ಟ್ ವಾಸ್ ಫಾರ್ಮೇಷನ್ ಆಯಿತು ಅಂತಂದ್ರೆ ಏನಾಗಬೇಕು? ಡಿಸಾರ್ಪ್ಷನ್ ಆಗಿ ಹೋಗಬೇಕು. ಓಕೆ, ಡಿಸಾರ್ಪ್ಷನ್ ಆಗಿ ಹೋಯ್ತು ಅಂದ್ರೆ ನಮಗೆ ಸಿಗ್ತದೆ ಅಂತ catalyst active ಆಗಿ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. Here the reactants adsorb strongly for catalyst to be active, but not adsorb so strongly, it does not provide surface for other reactant molecules. So here it does not provide. So here if or but not adsorb so strongly, it does not provide surface for other reactant molecules. ಭಾಳ ಸ್ಟ್ರಾಂಗ್ ಆಗಿ ರಿಯಾಕ್ಟೆಂಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ catalyst ಮೇಲೆ adsorb ಆಯಿತು ಅಂತಂದ್ರೆ ಅಲ್ಲಿ ಫಾರ್ಮೇಷನ್ ಆಗೈತಿ ಕಂಪ್ಲೀಟ್ ಕಾಂಪೌಂಡ್ ಫಾರ್ಮೇಷನ್ ಆಗೋಗ್ಬಿಡುತ್ತೆ. ಅಂತಂದ್ರೆ catalyst ಮೇಲೆ ರಿಯಾಕ್ಟೆಂಟ್ ಪರ್ಮನೆಂಟ್ಲಿ ಏನಾಗ್ಬಿಡುತ್ತೆ ಫಾರ್ಮೇಷನ್ ಆಗ್ಬಿಡುತ್ತೆ. ಹಿಂಗೆ ಫಾರ್ಮೇಷನ್ ಆಯಿತು ಅಂತಂದ್ರೆ ಫರ್ದರ್ adsorption ಅಂತ ಇಲ್ಲಿ ಪ್ಲೇಸ್ ಇಲ್ಲ ಆಗುತ್ತೆ. So this is about the activity. So here I will repeat once again. Activity means the ability of catalyst to increase rate of chemical reaction. So this is called as activity. So here the activity of catalyst depends on chemisorption or chemiadsorption. So here the reactant adsorbs strongly for the catalyst to be active, but not adsorb so strongly it does not provide surface for other reactant molecules. So this is about the activity. So next, second one, selectivity. So what do you mean by selectivity? So here the ability of catalyst to direct a reaction, ability of catalyst to direct a reaction to give particular product is called selective. So here selective is the ability of catalyst to direct a reaction to give particular product. So here the same reactants give different product by changing different catalysts. So consider, for example, hydrogenation of ethane. So this is the formula of ethane. Hydrogenation means addition of hydrogen. This is called as hydrogenation. So here hydrogenation of ethane in presence of nickel as a catalyst at 200 degrees Celsius to form ethane. So here in second reaction, hydrogenation of ethane in presence of lead in barium sulfate, it gives ethene. So here in this case reactants are same but catalysts are different. It gives different product. So in first case hydrogenation of ethane in presence of nickel as a catalyst at 200 degrees Celsius to form ethane 1. So here second example, hydrogenation of ethane in presence of lead in barium sulfate, it gives ethene. So here we are using same reactant but different catalyst, therefore we get different product. Consider another examples. So carbon monoxide react with hydrogen in presence of copper, it gives formaldehyde. So here carbon monoxide react with hydrogen in presence of copper, it gives formaldehyde. Similarly, the carbon monoxide react with 3 mole of hydrogen in presence of nickel, it gives methane with water. So here both the reaction contain same reactant but different catalyst, therefore we get different product. So here from this example it is clear that the product depends on selectivity of catalyst. So therefore it is about the selectivity of catalyst. Next we move towards the shape selective catalysis. So what do you mean by shape selective catalysis? So here the catalysis which depend upon shape or structure of pores of catalyst and size of the reactant and product molecules is called shape selective catalysis. So shape selective catalysis is the catalysis which depends upon shape or structure of pores of catalyst. So here PORES, pores of catalyst, and size of the reactant product molecules. Is called shape selective catalysis. For example, zeolite. So here zeolite is the good example for shape selective catalysis because selective catalyst because it has honeycomb-like structure. So here they are microporous aluminosilicate of silicates. So here they are microporous aluminosilicates with three-dimensional network. So they are microporous aluminosilicate with three-dimensional network of silicates which are formed by replacing silicon by aluminum. These are formed by replacing silicon by aluminum. So here zeolites are used shape selective catalysis. The reaction takes place in zeolites. It depends on size and shape of reactant and product molecules, as well as it also depends on pores and cavity of zeolites. So here zeolites are widely used as a catalyst in petrochemical industry for cracking hydrocarbons and isomerization. So for example, ZSM5 is zeolite silicone mobile. So here these zeolites are used for the conversion of alcohol directly into gasoline, means the conversion of alcohol into petrol. So here this is about the shape selective catalysis. So dear student, next assignment. First question, explain Morden adsorption theory. Second question, explain terms A. Activity, B. Selectivity. Third one, define shape selective catalysis with example. Dear student, solve these questions.